Yes, Assalamualaikum. Today we will be talking about isotopes. Well, actually, I had a complete lecture on isotopes when you were coming to classes in face-to-face class mode. But this recording of a video is in order to compensate for the loss of lesson time that we had, unfortunately, because of the poor internet connection. Anyway, so let us talk about the very question that why some elements have their atomic mass number not in whole numbers. This was one question which was pointed out by some student. I don't remember their name. But yes, so this very question is related to the topic isotopes. You have already done what isotopes are. We have discussed it. In fact, I've taken a quiz from you on this topic. So let me just go back to the topic isotopes. We are just going to revise it by just going through the definition, and then I'm going to associate this definition with that question. So isotopes are atoms of the same element. Now I'm repeating. It's the same element with the same number of protons but different number of neutrons. So isotopes of the same element, they have the same number of electrons. The isotopes have the same proton number but different nucleon number. So keep in mind, dear students, so isotopes are atoms of the same element, which means that if it is the same element, it's going to have the same number of protons, the same number of electrons, but the only difference in these atoms would be the number of neutrons that would vary in these isotopes. The rest, everything is going to be the same. With this variance in number of neutrons, you're going to observe that their mass number is different. Let's say, for example, chlorine has two isotopes. Clearly, one has got a mass number of 35, and another isotope of chlorine has a mass number of 37. Now, this implies that these are two isotopes of the same element chlorine, but they are actually varying from one another based upon their number of neutrons. So, in this case, the question lies that what atomic mass are you now going to consider? Are you going to consider the mass 35, or are you going to understand the mass 37? So the point is, you know, we actually have devised a formula which is going to calculate the overall mass of chlorine. And that's the point, where that question comes in, that why some elements don't have masses in whole numbers, because they've got isotopes. And because they've got isotopes, they've got different mass numbers. And unfortunately, we cannot mention that we are using these isotopes at the moment, or we cannot say that, okay, in this calculation, we are using chlorine 35, or in this calculation, we are using chlorine 37. Or you would just simply use one chlorine mass, and that is 35.5. So in that very situation, we have to bring in the abundance of those isotopes. We are going to multiply the abundance of isotope with their mass number, and then we are going to add that amount with the amount of another isotope. Let me just, okay, don't worry about it. We are going to do the complete calculation. You'll understand it. For example, if there are two isotopes of chlorine, and chlorine 35 is 75% abundant, which means that in this whole world we have got 75%, among all the chlorine that we have got, 75% of that chlorine will be 35, chlorine 35. Here, chlorine 35 means that it is the mass of chlorine, which is 35. And 25% would be chlorine 37. We are going to multiply the abundance of the chlorine with its mass number. In this next slide, we are going to see that we are going to multiply 75%, 75 by 100 multiplied by 35, and then we are going to add it with the abundance of chlorine 37, which is 25% multiplied by 100. 25 by 100 multiplied by 37. We are going to sum up both of the values that we get after multiplying the abundance with their mass numbers. Now we are going to get 35.5. Now notice that 35.5 is not a whole number. Usually atomic masses are whole numbers, but sometimes they are not whole numbers. This is because they have got isotopes, because that element is a mixture of isotopes. They have got different atoms, they have different mass numbers. What we do is we just multiply their mass numbers with their abundance, and this is how we just